Hello, and welcome to the ninth lecture of the Jabrah reinforcement learning series. So, in the previous lecture, we have been through a couple of reinforcement learning algorithms like policy iteration and value iteration. And what we saw from those algorithms was that they gave us a way for solving reinforcement learning problems where we had complete knowledge of the environment, where we can actually estimate all the probabilities of moving from one state to another, and so forth, right? But now we want to move onto a level whereby we remove some of these assumptions because in the real world, like actually knowing the probability distributions from one state to another is actually a very challenging task. Estimating such probabilities can be highly error prone, and we want to avoid that by finding other algorithms that may help deal with the situation, right? So, having said that, we come to our first reinforcement learning algorithm that we can use to avoid that assumption, called Monte Carlo methods or Monte Carlo simulation, depending what you want to call it. So, like I said, when we were dealing with value slash, let's say, policy iteration, we were using dynamic programming to solve this, so let me just call it DP methods, right? Since we're using dynamic programming methods. So what we did was assume complete knowledge of the environment, right? So basically we assume that we know this distribution of moving on to a future state given you in a current state and the reward that you get after taking a particular action. So this is kind of the assumption that we made, right? That we have a complete knowledge of this environment. But of course, when we're dealing with more realistic situations that we might want to apply our reinforcement learning algorithm in, like we might not always have this knowledge, right? So we might need to actually infer or make some kind of estimation of what this distribution might be, right? So Monte Carlo methods allow us to do that. So there's no real need to actually generate any complex distribution like we need to do in this dynamic programming methods, right? So first of all, before we get into the details of how Monte Carlo simulation actually helps solve us for in solving reinforcement learning problems, let's first look at the term itself, Monte Carlo, right? So without going into all the intricate details, Monte Carlo is just an estimation method whose operation involves a significant random component. So an estimation method whose operation involves a significant random component. So having like read through that, like the first thought we might have to solve is like, how does this apply to us, right? What is the random component that we're trying to estimate? Well, if you remember, like the whole point of this reinforcement learning series is that we are trying to estimate, for instance, a value function under some policy pi in S, right? And we actually say that this is an expectation over pi, right, of gt, where gt is the return given S. So this is essentially the very estimation that we want to like compute and if we actually break it down, if you remember, this is actually dependent on RT plus 1 plus gamma GT plus 1, right, which means that we have all these rewards and the future state that we end up in, and we don't actually know um, the values of these rewards, right? So we're trying to compute an expectation of what we think those future rewards are going to be. And since this is a random component, this means that applying Monte Carlo methods is something that is feasible and something that we can actually try to do to solve all these kind of problems. Right? So, having said that, let's go into greater details as to how we can solve for reinforcement learning problems using Monte Carlo methods. Right? So first of all, just as we started with when we were dealing with policy iteration, we said first we look at policy evaluation and policy improvement. So we called policy evaluation as the prediction, and the policy improvement was control. So in the same way, we're gonna start with Monte Carlo prediction, right? So since the prediction method, what does that mean? Since it's prediction, that means that we are given a policy, and using that policy, we want to estimate what is the value of that policy, right? The value function for that policy, right? So given basically pi, right, we want to estimate v pi, right? So basically we're given pi, and we want to estimate v pi. That's actually the goal. This is the same goal we had when we were dealing with policy evaluation. And as you remember, the policy improvement phase was actually trying to get a better policy, right, given some initial policy. So if you don't remember that, please look at the previous lectures on policy iteration, and this is going to be important because we are applying the same principle here. First of all, in this video, we're just going to mostly focus on the Monte Carlo prediction phase, and after that, we're going to go into Monte Carlo control, right, which is actually improving our policy and so forth. So, having said that, there are two kind of Monte Carlo methods that we might actually want to look at when we dealing with Monte Carlo simulation and stuff. So the first thing is first visit Monte Carlo methods, and the second is every visit Monte Carlo methods, right? So we have first visit and we have every visit. That's the general idea here. So what we have here is like we first need to define like what is a visit. For us to be able to understand that, we need to go through a couple of things, like what are we trying to do in Monte Carlo, right? So we're trying to actually, you know, like we said before, we're not assuming any knowledge of the environment. We are given a bunch of episodes, and from these episodes, we're actually trying to gain the average returns and, you know, estimate the value function based on that. So if you don't remember what an episode is, so basically if we're given S0 and we need to take an action A0, we get a reward R1, end up in a state S1, take another action A1, and so forth until we'll reach that terminal state, right? This is what we call an episode, if you remember. So this is one episode, right? So what we need in Monte Carlo simulation methods are a bunch of episodes. Why do we need this bunch of episodes? We need these episodes because it is from these episodes that we're going to infer the actual value functions, right? So we're actually doing some kind of sampling, right, from a lot of episodes, and using this we can actually estimate how valuable it is to be in a particular state, right? That's essentially what it is. So we simulate a lot of episodes, and using those episodes we try to actually compute, you know, the expected return from a particular state and so forth, and kind of average these returns throughout a lot of episodes. That's what we're doing in Monte Carlo methods. So what does this mean? Um, what we can think about is a visit here. We're referring to a visit to a state, right? A visit to a state. So, for instance, in this episode, right, uh, we will start at some state S0, right? And we're gonna go through a sequence of events, right? And then maybe at some point we might actually come to the same state again, right? So let me give you a simple example. Like, let's say this is our environment, a simple grid, right? And this is position, let's say this is P, okay, maybe not use this, but I can say maybe this is SN, SN, actually let me use a better, a simpler representation. Let me just say B, C, D, E, okay, that will make things very simple. Yes, okay. So these are our states who can be in B, C, or D, or E, right? And let's say someone gives you a policy. So this is the policy that you're given. And the policy is we start from state B, and the policy is move right, move down, move left, move up, and move right. Okay, this is actually the sequence of events we're going to follow, right? So basically what this means is that from B we'll be in state C, and then we'll be state E, and then we'll be in state D, we'll be in state B again, and then we'll be in state C. So we're just moving like this. This is how we're moving through this grid, right? So we move there, then we move down, we move this way, that way, and back this way. This is essentially what this is. So this happens at time step. We'll call this ST. Let me use a different color here. So this happens at ST plus 1, ST plus 2, this is plus 3 plus 4 up to ST plus 5, right? This is the sequence of events that we have and the time steps that we're following. So what is first visit Monte Carlo saying, right? So let's say someone says like, can you please estimate the value of being in state C, right? So you want the value function under policy pi. This is our policy pi here. This is our policy pi. And so the value function under policy pi of C, right? So this is what we want to estimate using Monte Carlo methods. So Monte Carlo methods only estimate, like given an episode, they only estimate the return after the end of the episode. That's when we update our value functions. We don't update our value functions during an episode, but after an episode actually ends, right? So for instance, here we have a simple episode where we started from state B. I should probably add it here, B at ST0, at time step 0, we were at B. And then we move to C, E, D, B, C. No, we want to actually find the value of being in state C, right? So actually let me make this, it's okay. So in first visit Monte Carlo methods, all we do is we compute the return starting from this point here, right? So starting from C, we actually compute the return and then we average it, right? But we don't actually look at the second C. So what do I mean by that? In every visit Monte Carlo methods, we actually average the returns from every single visit to a particular state, right? Given an episode. That's what every visit means. But in first visit, we only compute the return after the very first visit to a particular state given an episode. So in first visit, we only look at this C and we compute like the expected return starting from this C, right? On the other hand, in every visit, we're going to compute the return starting from this C, and we're also going to compute the return starting from this C, right? So we'll compute the return from this C, compute the return from that C, and we're going to average it, right? So the same goes for v pi of b. If it's first visit, right? If it's first visit, we only look at this b. This is first visit. Only look at this b and compute the return starting from this b. But for every visit, like we have to look at this b and this b. So this is for every visit. We have to look at both b's. And what are we doing with this? We're using this to actually compute the return, right? Starting from those dates. So this is the essential goal. We're trying to estimate the return starting from a particular state. This is and actually kind of average those returns. That's what we're doing in Monte Carlo. Now, if in case this wasn't actually clear, I'm actually going to go through the pseudocode now, and this should actually give you a better idea of what we're trying to accomplish. And in this case, we'll be focusing on first visit Monte Carlo methods, not every visit Monte Carlo methods, but just the first visit. So that means that we just look at the first occurrence of a state, compute the return from the state in a particular episode, then do it for the next episode and the next episode and the next episode, and we're going to average out all those values. That's how we compute the value function for a particular state. Having said that, I'm going to start with the pseudocode. So we're starting with the first visit Monte Carlo methods, right? That's what we want here. The first visit Monte Carlo method. So, first of all, we need to do some initialization, right? So we initialize pi, right? This is our policy to be evaluated, right? And our v, what is v? As you know, this is our state value function, right? And then what are we trying to return? We're just trying to actually compute the state value function. So how are we going to actually do that? So this is kind of like v of s, right? State value function, maybe we can initialize it in the beginning to 0, right? So initial value will be 0 for this state value function. So we repeat the following procedure, right? What are we repeating? First, generate an episode using pi. Of course, you might think to yourself like, if we generate this episode using pi, from what state are we supposed to start from? Are we going to start from the initial state? Are we going to randomly select the state that we start from? Or are we going to use a more intelligent technique to start from a particular state? And this is a very valid question because depending on the technique you used, the results will differ greatly. So it's very important to have a very good initialization methods for the policy. And in the future videos, we're actually going to go through such initialization methods that would give us the best results that we want from like using this. But for now, you can just ignore this. Like, you don't have to focus on it. Just assume we're having some great initialization method and we're just using that to generate an episode using pi. So we're generating an episode using pi, and you remember what an episode is. So for each S, right, in episode, what are we gonna do, right? G is the return after first occurrence of S. So G is not the return after the end of the episode, but the return starting from the first occurrence of S and the actual return we end up getting, right? So this is what G is. Return after the first occurrence of S, right? So what are we gonna do this? Let's actually define, I think we should define, okay, we've defined this too. Let me define a third uh, variable called return S, right? Let's just start this as an empty list. So this is what this is, return S. Just think of it as another member variable, another variable, sorry, in the initialization phase. So we're going to append G to return, right? We're going to append G to return, and then VS, right, should be the average of the return. Okay, so we need to average out the returns. That's how we do these things with the first visit Monte Carlo methods. So there's something important here. If you think about it, so like what is actually a return here? Return S, right? That means like, okay, maybe we have a bunch of states. Let's call this state S, this state S prime, this state S double prime. These are all just different states. Don't think of it as a time step perspective. Just think of them as different states, right? So initially, these states are empty, right? So this is actually our, I'll just call this our state space S, right? This is what this is. This is S, all of this. So as we're actually going through these algorithms, we're actually going to get some values. What is the return? Maybe here it's 2, here it's 3, here maybe we get 4, 5, and 7 or whatever. We're just getting a bunch of random, not random values, but actual returns from some episode that we're generating, and maybe this is just seen in one episode. So this is like episode 1, this is episode 2, this is episode 3, right? This is essentially what this is. So these are the returns that we got from these states in these different episodes. So what are we gonna do? We're going to average all of these states, right? And this will give us what? Our value function for S, capital S, whatever. So this is what gives us our value function by taking the average of all these returns that we get. So in episode 1, we get the return 2 in this state, return 4 in this state, return 1 in this state, and return 5 in that state. In episode 2, we also get a bunch of returns. In episode 3, we get a bunch of returns. Average out the returns, and then we get the value of being in that state, right? So as you can see, we are not actually estimating an actual model or the four-change function P S prime comma R given S comma A. We're not actually estimating that. We're just directly estimating, creating like some episodes, sampling out what the returns might be. So as a whole, this is actually how it's actually quite simple if you think about it. Like we're just using the episode to just sample out the values of being in particular states and just average them throughout different episodes. So knowing that, you should actually think about the possible problems we might have in this approach. One of them I already mentioned, like how do we actually decide where to initialize, because this initialization is very, very important, right? Like how we actually initialize the policy. And there are different actual methods that we could use to do that. We're gonna go through that, of course, in the next video. But for now, this should be enough as a simple introduction to Monte Carlo methods. Thank you kindly.